Hi, we want to talk about Chapter 8 of Python for Everyone version 3 on sets, and then maybe I do another one for dictionary. So that's what we're going to be talking about today. Uh, that would be 8.1. So when we're talking about the set, we can think about it not comparing to the list. So we talked about the list, and we said that inside the So inside Python, when we're using Python, they're using a lot of lists. So we're moving on into data structure that's called set. So it's different than a list in a way that sets are unique elements. That means you cannot have any duplicated cells in sets. And you might have seen sets in your math classes or some other STEM classes. That What I like about this is a pictorial of how things are. So if we're looking at a set for each flag here, you can see that there is only one type of color in each one of them. So there is no duplication. So when we say we have a set of colors, that is going to be only one of each. So if I have a list of numbers and I want to put it in the set, the duplicate is going to go away. I know some of you knowingly or unknowingly, when we were talking about removing a duplicate in the list, you force it to be a set and then the duplicate went away. So we're going to talk more about this. So how do we create a set? Remember the way that we were doing the list, it was a square bracket. For the list, we will use a curly bracket. So that's the way we're going to create a list. And the thing about the list is it is not in any order. So sets, set elements are not ordered. So you put them in this order, you put the first one, second one, third one, it is not going to stay in that order, or it's not going to be saved in that order. That's what your book is using something similar to this one that is not right after each other. It's going to be in some order somewhere. And So two things about the list. They are unique and they are not in any orders. These are the way that most of the databases are created using the sets. So if I have a list, I can typecast it to be a set. But if I have any duplicates, those duplicates are going to go away. So remember how we did the set with the initialization? So we have some three elements in there. So if I want to create just a set, empty set, this is the way we're going to do it. So we're going to create a empty set by using the word set and parentheses. So basically it looks like a constructor, you're calling a default constructor type of thing. And that would give us a set pointing to a location with an empty. So we can call the length for the set. That's going to tell us how many elements do we have in there. So in this case, it's going to be 0. So empty set, having braces for uh, putting the initialization and having a length to know how many elements do we have in the set. Now we can use the if statement and use the word in like we were having it before. So we can use in to check to see if element is in our set. So we can check it. If it's there, it's going to return true. If it's not there, it's going to return false. So how do we go through our set elements? Just like the other ones, we can use our typical for loop. So we can say something like for this in our set. So it's going to go through the set and it's going to pick up each one of them. It's going to put it in this and we can print it. So again, if I put it in certain order, when I print it, doesn't mean it's going to print it in the same order. There is no order in set. So what about if I want to sort it? So if I use the word sorted, we're basically going to take the set and we're going to change it to a list, which is going to be sorted. So the set itself cannot be sorted because there is no order in the set. But we can basically cast it into a list, and then we can go through the list in a sorted order. If we want to add the elements to the set, so keep in mind what's going on over here. We are taking a list, we are typecasting it to a set. So we have 3 elements in there in no order at all. Then we're going to be using the add to add one more to it. And then we're going to use add to add one more. So every time we want to add, we're going to add one more. It does not put it at the end. There is no order in it. That's something that we have to keep in mind in the set. So how do we remove it? We can use the word discard. So the discard is going to discard it. Now, if the element is not a member of set, nothing is going to happen. So if the element is not just like if you add, and if the element is there, it's not going to do anything because we don't have any duplicate. If you discard and it's not there, it's not going to do it. So that's for that one. Now, sometimes we want to know if the element is there or not. So we can use, instead of discard, we can use the remove. And if the element is not there and we're calling the remove, it's going to raise an exception. We might want to do that, handle exception. We want to check to see if it's there or not. Or we could just check it to see if it's in the set or not. So if I want to remove everything in my list, that would be clear. The clear function is going to remove everything. We're going to go through sets. I think you have that in one of your math classes, talking about the sets and how we're going to do those things. So we're going to talk a little bit about math part of the set. So we have a few things that we want to visit over here. One is the subset. So if we have a set that contains partial of the other set, that would be considered subset. So this Canadian flag has red and white, British has blue, white, and red. So we can say the Canadian is a subset of the British flag. But if so that means what? The subset, the smaller set, has to have everything that the other one has. Otherwise, that would not be a subset. We have a method that we can call, that's called is a subset. We can check to see if one set is subset of the other one. Of course, if you have just the few of them, visually you might see it, but if you have lots of them, you might not be able to see it. If I have 10,000 elements in one set and 1,000 in the other one, I want to see if all of the elements of the smaller one contains in the bigger one. I can use the word is subset. So I can say use Canadian dot is a subset of British. It's going to be true, but Italian is not subset of this. So we're going to be using a not, and that would be true. So how do we check to see if the two sets are equal or not equal? So we can use the equality, not equality. So we're going to check two sets, and if they all have the same elements, that would be equal. If they don't, they are not equal. Again, no order. Union. The union contains the elements of both sets. The intersection is what do they have in common. So I said that wrong. So intersection is what do they have in common. Union is whatever is they have by both of them. Difference. So what is in one that doesn't include in the other one, that's the difference. So if we have Italian difference British, it's going to give us green. And if we do it the other way around, it's going to give us the blue. So if we had British that difference Italian, it would give us the blue. If we say Italian that the difference British, it would give us the green. So the set operation that we can create an empty set. We can create an empty set. We can get a sequence and put it in there. Or that would be like a list type of thing. Or we can put it element by element in braces when we are creating it at the beginning. After that, we can use the add to add the elements to our set. We can use the list to see how many elements do we have. We can check to see if an element is there or not there. We can use the discard and remove. Remember that the remove is going to raise an exception if it doesn't exist in there. We can use the clear to remove everything from the set, and we can check to see if one of them is a subset of the other one, meaning it has all the elements of the other one. We can check to see if they are equal or not equal. That would turn in true or false. We can check the union. That would be having all the elements of both of them. Intersection is what do they have in common. And the difference is you have one, you have the things that you have in one and doesn't include in the other. So this example that we can create a set and we can open a file, we can do our strip and then split it uh, on these things. Uh, so whatever we have not A to Z or capital A to Z, we're going to remove it. We're going to split it on base on that one. And then we're going to add the lower one. We're going to change it to lowercase and add it to our set. So when we are talking about collection of unique items, the set would be very efficient. It's going to be a faster and more efficient way to use the set. Uh, So you might want to check to see before you're adding something to the list, and you to be sure that it's not there before you try to add it. Uh, Technically, when you're doing the sets, you're doing it a little different. So you're going to be just adding, and if it's there, it's there. It's not there, it's going to add to it. So there are some example in here that you can go over it by yourself. So if I'm looking for unique words, we can take the word, put it in set, and then we can count to see what the length of it and find how many we have. So this is what you need to do for your homework and lab. So you have 5 steps that you have to go through. First is you have to understand the task. Do you understand the task? So you have to be sure that you understand the requirement. That's the first step. And then step 2 is decompose the problem. So you take the task, you break it down to the smaller task, and you can potentially create modules or functions for them. Step 3 is you're going to be building a set. So clean up whatever you need to do, and then you create your set. Step 4 is clean the words. So whatever you have in there, you're going to clean it up. And step 5 is you're going to do some assembly and create your main function. So be sure you're going to go through these steps to do your homework and lab this week. Okay, I'm going to stop this one and I'm going to come back to the dictionary.